I am Anil Kumar. Welcome to my series on inverse trigonometric functions. In this video, we'll learn very important method of substitution to work with the inverse trigonometric functions. In case you want to learn from me, you can always send an email on the address given. You can also check our website for the new videos being uploaded. Now here I've summarized all what you need to know before getting into this particular exercise. Now, for any expression which is kind of given in this column, the substitution is given right opposite to it. So if you have a square plus x square, a substitution for x equals to a tan theta or a cotangent theta will work. If you have a square minus x square, in that case the substitution is a sine theta or a cosine theta. For x square minus a square, substitution should be a secant theta or a cosecant theta. If you have within square root these terms a plus minus x, in that case we'll use the double angle formula, and the formula will be x equals to a cos 2 theta. So I've also given you the related double angle formulas right across, which you should remember moving forward. Once you do this substitution, you may be required to simplify the expressions, and therefore these related formulas will help you. If you have a square with plus minus x square, in that case the substitution will involve x square equals to a square cos of 2 theta. Correct? So with this combination of the compound angle formulas, especially the double angle and the half angle formulas, you will be in a position to simplify the trigonometric expressions or evaluate them if required. Now, once the substitution is done, after that, when you simplify, simple trigonometric Pythagorean ratios relation, which is cos square theta plus sine square theta equals to 1, or 1 plus tan square theta equals to secant square theta, and also 1 plus cot square theta is cosecant square theta, can help you get the result. We'll actually solve the most complicated question will be something like this shown here. So such examples. Before getting there, we'll develop the methods and see how to use these substitutions to get the results, right? So let's go. There will be 6 examples. One by one, we are going to take them and then see how do we work with these substitutions. In example 1, we have two part A and B. Tan inverse x over square root of 1 minus x squared. Now clearly the denominator is only defined for x between minus 1 and plus 1, right? So therefore we have taken that as the argument. Now in the second case, we have sine inverse of x over square root of 4 plus x squared. So x could be any value in this case. So these are the two examples to begin with. You can always pause the video, use the type of substitutions which we have just talked about, correct, and then see if you get the answer. Here is my solution. So clearly, in this case, we have 1 minus x squared. So when you have 1 minus x squared, a is 1 for you. So you can use the substitution x equals to sine theta, correct? You're looking for tan inverse. So what do we want? We want inside somehow to become tangent. Tangent is sine over cosine. So that gives you a hint why we should be using x equals to sine theta, correct? Now see how it works out. When you substitute x equals to sine theta, the numerator will be sine theta and the denominator will be square root of 1 minus sine square theta. Now you know sine theta is in the numerator, 1 minus sine square theta is cos square theta. So we get square root of cos square theta. Clearly, this is equals to tan inverse of what? Tan inverse of sine theta over cos theta, correct? So you get tan inverse of sine theta over cos theta, which is tan theta. Tan inverse of tan theta is basically equals to theta, and therefore we get theta as our answer. But see what? We had x equals to sine theta, correct? So from here we can find what theta is. Clearly, theta is sine inverse x. Do you get the idea? Therefore, the answer is sine inverse x, which is the value for theta. So that is how you get your result. So I hope these steps are absolutely clear. Let's again take similar steps for the next question, which is sine inverse of x over square root of 4 plus x square. What should be the substitution? Well, 4 means 2 square, right? So think like this. What we have here is x over square root of 2 square plus x square, correct? So that is what you have. So therefore, we'll take a substitution, which in this case will be x will be equals to 2 tangent theta, right? Remember 1 plus tan square theta is secant square theta. So that will give you secant square theta square root within the denominator, right? So that is why this substitution always works. So we'll replace x with 2 tangent theta and x square also, 2 tangent theta whole square. When you open this bracket and then try to solve this, what do you get? Well, you get 4 times 1 plus tan square theta, which is secant square theta, right? 2 and 2 will cancel. So you get tan theta over secant theta. Now, what is tan theta over secant theta? Let's work it out, right? So tan theta over secant theta, tan is sine theta over cosine theta, correct? And secant theta is 1 over cos theta. Now clearly you can cancel the cosine thetas, and what you get is sine theta. So we get sine inverse of sine theta. This is important, right? To solve this, that's a strategy. So we get theta as a result, and when you get theta as a result, now from here you can find what theta is. Well, clearly theta is equals to, you'll divide x by 2 and then take tan inverse. So theta is equals to tan inverse of x, and that is what? X by 2, right? So theta is, you'll divide x by 2 and then do. So theta is tan inverse of x by 2. Sorry for that. So this is what you get. So your answer in this case will be tan inverse of x by 2. Clear? So that becomes the answer for the given question. Is that clear to you? That is how we are going to solve all these questions, correct? Now let's take example 2, where we are going to understand the other substitution strategies. Now in this case, what do we have? We have cotangent inverse, correct? We have cotangent inverse. We want to get cot theta within the brackets. This is the whole strategy. Perfect. Now the question is cotangent inverse of x over a square minus x square within square root, where again domain has been restricted to, it should have been plus minus a, right? A. So it is, this domain is between minus a to plus a. Okay. So that is the restriction on the domain. Right. Only then you have the denominator valid. Now, we'll make a substitution when in this case x equals to a cos theta. So when you substitute a cos theta, you get the expression a sine theta over a square minus a cos theta whole square. You can take away a outside the bracket and later cancel them. And within the square root, you get 1 minus cos square theta, which is sine theta. And cos over sine is cotangent, cancelling away a. We get cot inverse of cot theta, which is theta itself. Now theta will be equals to cos inverse of x by a. And that is how you have to solve this particular question. Clear? The next question here is cos inverse of x over a square plus x square. Now in this particular case, the substitution which we are going to do is, since it is a square plus x square, right, we'll do x equals to a cotangent theta. The idea is to get cos theta within the argument, right? So when you substitute cotangent theta for x, you get a cot theta over a square and a cot theta whole square, taking a common and cancelling it away within this argument. We get cotangent theta over square root of 1 plus cot square theta, which is cosecant square theta, right? With the square root, what do you get? You get cot theta over cosecant theta, right? So which is equals to cos theta. Let's work this out. So you have cot theta over cosecant theta. Cot theta is cos theta over sine theta, correct? And cosecant is 1 over sine theta. Now, sine theta and sine theta cancel. What is left with? Cos theta, correct? So that is how we get our argument as cos theta. Cos inverse of cos theta is theta, and we know what theta is. That is from the substitution. You can see that theta is equals to x over a cot inverse theta. So we get cot inverse theta x over a, correct? Because you'll first divide by a, x over a, and then you take inverse of cotangent to get the answer as shown here. So that becomes your solution. Is that clear to you? Now let's continue with example number 3, where we'll learn the third type of substitution. The question now is cosecant inverse of x over square root of x square minus x a square, and part B is secant inverse x over square root of x square minus a square. They are very similar questions, so I'll explain you the very first one and you can go through the solution of part B. Now in the very first one, we'll do what substitution? Well, substitution is x equals to a secant theta. So when you replace x with a secant theta, you get cosecant inverse a secant theta divided by a secant theta whole square minus a square, taking a common, which will be cancelled later. We get secant theta over secant square theta minus 1, which is tan theta, you know. And now, secant theta over tan theta is cosecant theta. You can work it out as we did for others earlier. So, what do we get? We get theta as our answer, and from here, you know what theta is. Theta is secant inverse of x over a, and that is what we get as our solution. Clear? Correct as shown here. This is how you're going to solve that. The next one here, notice, since we have secant inverse, substitution used is a cosecant theta, correct? And we'll follow the same process. And once you simplify, you get within the argument as secant inverse of secant theta, again theta will be your answer, x over a, and then you're going to take the cos inverse, and so you get theta as cosecant inverse of x over a, which becomes your answer. Is that clear to you? That is how we are going to solve these questions. So that becomes the foundation for you. How do we use the substitutions to solve, right? Now, in this case, we are taking within square root both numerator and denominator terms. So now when it is both of them together, then we go for cos 2 theta, or even cos theta can work for us, right? So I've taken here two examples just to show you that we could work with either cos 2 theta or cos theta. The only thing is you get theta by 2, which will be resulting into the same answer. Okay, so let's work it out. So in this particular question, we're talking about tan inverse square root of a minus x over a plus x, where x is between minus a to plus a. Substitution will be a cos theta. When I replace x with a cos theta, I get tan inverse of a minus a cos theta over a plus a cos theta. A is common, which cancels away, leaving with us 1 minus cos theta over 1 plus cos theta. Now you know these formulas, correct? So what is 1 minus cos theta? So clearly from here, 1 minus cos theta is 2 sine square theta by 2, correct? So that is what you get from here, 2 sine square theta by 2. You can work on this, right? 2 sine square theta by 2 is cos theta minus 1. Rather, one, this is wrong. Wait, let me correct this. So when you simplify this, you can take 2 sine square x on the left side. So we get 2 sine square x equals to 1 minus cos 2x, correct? Writing with half angle, you get 2 sine square, let's say theta by 2. Let me write 2x here. Let's say x is equals to theta by 2. In that case, 2 sine square theta by 2 will be 1 minus cos of theta, right? So that is how you're going to write it. So what we get here is 1 minus cos theta is 2 sine square theta by 2. Similarly, 1 plus cos 2 theta will be equals to, you can derive from here, right? So you get this formula. The 1 plus cos theta is 2 cos square theta by 2. 2 and 2 cancel. You get square root of tan square theta by 2. Now in this particular case, tan square theta by 2 square root is equals to absolute value of tan theta by 2. Now, in this given domain, tan theta by 2, tan inverse of tan theta by 2 is theta by 2. So we get our answer as theta by 2. Now what is theta by 2? Well, let's figure it out. From here we can say that x over a and then cos inverse. So we can say theta is equals to cos inverse of x over a. Okay? Theta is cos inverse of x over a. Theta by 2 will be half of that, correct? And therefore, we can write down our answer, which is going to be equal to half of cos inverse of x by a, correct? So that becomes the answer. So let me write down the solution here, which is the answer as half of cos inverse of x by a. Is that clear to you? So that becomes the solution. Perfect. So now we had tan square theta by 2 within square root. So remember one thing, that is x square square root is basically equals to absolute value of x. Now how do we normally work with this? So let us look into this part also. We are given the domain that x is within minus a to plus a. Now, so theta will be what? Theta is going to be between 0 to pi for tangent for this, for cosecant theta, right? We are talking about the inverse of cos theta, right? So theta is between 0 to pi, which gives you all the values. Now, theta by 2 will be between 0 to pi by 2. And within 0 to pi by 2, we know that tan theta by 2 is always positive. And therefore, we took it as tan theta by 2. Is this part clear to you? So that is how you have to work with the given domain also, right? So that is how we'll actually work and justify that the absolute value of tan theta by 2 is tan theta by 2. So tan inverse of tan theta by 2 is theta by 2. Since theta is cos inverse x by a, we have our answer, which is half of cos inverse x by a. Correct? Okay. Let's take example 5, which is very similar to the previous one. Now in this case, let us see how do we solve this question. We have a square minus x square, a square plus x square within square root as our argument. The question is tan inverse of square root of a square minus x square divided by a square plus x square, where x is between minus a and plus a. The substitution which we have done here is equal x square equals to a square cos theta. So when I substitute a square cos theta, in that case a square can be taken common. We are left with 1 minus cos theta over 1 plus cos theta. Clearly 1 minus cos theta is 2 sine square theta by 2 and 1 plus cos theta is 2 cos square theta by 2. Now that gives you absolute value of tan theta by 2 within the argument. And clearly, as we worked out last time, within this interval, theta x between minus a and plus a, the value of theta will be between 0 to pi by 2. And theta by 2 will be between 0 to pi by 4. Now within this interval, the absolute value of theta by 2 tan is tan theta by 2. So we get theta by 2 as our answer. And that gives you the value of our theta. Of course, from this we have x square over a square, right? And then we'll find the cos inverse. So we get, we can write half of, and the value of theta is cos inverse of x square over a square. Clearly, that becomes our solution, right? So that is how we are going to answer this question, right? Now I think you're ready to take up the challenge question, which is right here before you. You can actually pause the video now, solve the question, and then look into my solution. Copy the question. It is proved that tan inverse of square root of 1 plus x minus square root of 1 minus x divided by 1 plus x, 1 minus x within square root is equal to pi by 4 minus half cos inverse of x, where x is given to you between 0 and 1. Now we can do the cos 2 theta as our substitution. We have seen earlier, if you could use cos theta also, then you get answers with theta by 2. We did substitution cos 2 theta to avoid theta by 2, right? Anyway, the answers will be similar. Okay. Now in this particular case, we get 1 plus cos 2 theta within square root, 1 minus cos 2 theta. Those are the terms which you get within the square root. Using our double angle formulas, we know 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta, right? Substituting these, we get the next step, which is tan inverse of square root of 2 cos square theta minus square root of 2 sine square theta over 2 cos square theta plus square root of 2 sine square theta. Now, we're working within the domain x is between 0 to 1, and we have substituted x with cosine of 2 theta. Therefore, cos 2 theta is between 0 and 1. Now, if cos 2 theta is between 0 to 1, a positive value, in that case 2 theta has to be between 0 to pi by 2. And dividing by 2, we get theta is between 0 to pi by 4. So that clearly means that the absolute value of cos theta will be cos theta and absolute value of sine theta will be sine theta. Correct? So therefore, when we do the square root of 2 sine square theta, we get absolute value of sine theta. Square root of 2 cos square theta is absolute value of cos theta. But for the given domain, where x is between 0 to 1, both are positive. And that is how we are going to simplify it. So we get tan inverse of cos theta minus sine theta over cos theta plus sine theta. Dividing by cos theta, you can write this expression as 1 minus tan theta over 1 plus tan theta in the argument of tan inverse function. So tan inverse now becomes what? Well, you know tan A plus B formula. So from there, we can write this as tan pi by 4 minus theta. Correct? This is a very critical step, and I hope you remember. Tan A plus B is what? Tan A plus B is tan A plus tan B over 1 minus tan A tan B. And you know tan pi by 4 is 1. So if I have tan of pi by 4 plus the angle, which is, let us say, some angle theta, in that case, I get what? I get 1 plus tan theta over 1 minus tan theta, correct? And that is how we get this expression, correct? So since in our case we have minus on the top, right? We have minus on the top, so we will do, if I have minus here, let's say if I have minus, in that case this becomes minus, that becomes positive. Clear to you? Perfect. And that is what we have. So we get our expression as pi by 4 minus theta, right? Tan of tan inverse pi by 4, and that is equals to pi by 4 minus theta. Theta, from here you can calculate theta is what? So it is cos inverse of x divided by 2, which is half of cos inverse x. Okay? So we replace theta with that. So we get our result as pi by 4 minus half cos inverse of x as the answer. Clear? That is how we are going to solve it. I've also shown the calculation. X equals to cos 2 theta. Theta is equals to, sorry. So you could do two steps here. So you could also do here. First you can get 2 theta is equals to cos inverse of x, and then get to the result, which is half of cos inverse of x, and that is how you get your result. Is that clear to you? Very important question from test point of view. So have a good look at it. For your practice, here is the similar question with some difference. Now, I like you to pause the video and do this particular question. which is kind of similar. Tan inverse of square root of 1 plus x square plus square root of 1 minus x square divided by 1 plus x square minus square root of 1 minus x square. And the result expected is pi by 4 plus half cos inverse x square. Now in this case, you can actually pause the video and solve it on your own. Okay. So the only difference with the previous one is instead of x, we have x square. So when that term comes, it is x square which is substituted as cos theta, cos 2 theta. Then you follow the same steps, correct? When you do that, what do you get? You get absolute value of cos theta plus absolute value of sine theta divided by absolute value of cos and sine. Now, where we are looking into the domain, x is between -1 and +1. So x square will be positive, correct? We substituted x square as cos 2 theta. It has to be between 0 to 1. So theta, in our case, will be between 0 to pi by 4, which results into positive values for cos theta absolute and cos the sine theta absolute, right? So the value of x is positive sine and cos. Another important thing is the substitution, which we did was x squared equals to cos 2 theta. That means that what is theta? Theta is half of cos inverse of x squared. Now taking that into consideration and the formula, which we learned about 1 plus tan theta over 1 minus tan theta is tan pi by 4 over theta, right? So we get our result, which is tan inverse of tan pi by 4 plus theta is pi by 4 plus theta, and you know theta is half cos inverse of x squared, and we get a result. Perfect. That is how it should be solved. I'd like you to work through these examples. The important thing which you should mark here is one, the substitution, correct? Once you do the substitution, you have to simplify the result. That means remembering the compound angle formulas, right? So that is kind of important. So second is to simplify. Also work with the domain, right? This is very important. Working with the domain. So with the domain, you understand what should be the value for the absolute equivalent of these functions and writing down the answer. After the substitution, also see how do we get your theta value back with the inverse functions, and that will be a part of your solution, clear? So that is how you have to do it. I hope these steps are absolutely clear. So with this, we end our lesson where we learn with the help of examples how to do all these substitutions. Perfect? Also, after doing the substitutions, we do get a simplified expression, but then you have to remember these compound angle formulas, which can be simplified as these. Do you understand, right? So most of the time, we were using the square type of a thing, which is this could be written as what? We could write this as 2 cos square x by 2 equals to 1 plus cos x. Clear? So likewise, we wrote all these formulas, applied them. Once you do that, then you get a very simple trigonometric expression to solve, and that gives you an argument which is kind of similar to the expression. So we get normally a term which is tan inverse of tan theta, cos inverse of cos theta. That helps you to find the solution. Perfect. You have to also work with the domain so that you understand that square root of x squared is basically absolute value of x. Now, should this be equal to positive x or minus x, right? It really depends on the domain. Do you see that? So that is kind of important to understand, and that helps you to get the right answer. Perfect. So I hope all these steps are absolutely clear. Feel free to write to me on the given address. Write your comments and share my videos. Thanks for your time and all the best.